Alright, so today we are solving differentiation, composite, implicit, and inverse functions under the course calculus. Yes, I'm going to try to find the derivative of cos x times the x to the power 6. Here is our work. Step 1, this is the product of cos x and x to the power 6. So use the product rule. So the product rule as she wrote here, which is uv. So so u should be outside. Here u is outside, differentiation of v, and differentiation. Okay, so u differentiation of v, v differentiation of u. Find the derivatives of the factors. So cos x is negative sin x, and differentiation of x to the power 6 is 6 to the power 5. Putting it all together, we have, what do we have? So x to the power 6 times differentiation of this, which is negative sine x, positive cos x, differentiation of this, which is 6x to the power 5. Now what they have got, 6x to the power 5 times cos x, negative sine x times x to the power 6. And this, our working matches with the correct answer. Yes, she's correct. Alright, so let gx equals to be root 2x upon ln x, and we are told to find the differentiation, the g prime x. So this is the quotient rule, where we square the denominator and we keep the denominator as it is, multiply it with the differentiation of the numerator. So root 2x is just root 2 times x to the power half, because root of root x just basically means half, and we can, using the laws of indices, we can split them, because if we can say that the square root is on 2x, then it is on, like, it is the same as writing root 2 into root x. So if we differentiate this, it becomes root 2 times half x to the power negative half. So root 2 times half x to the power negative half. So plus, now we keep this thing constant, sorry, negative, not plus. So ln square, ln x square, and ln x times root 2 into half into x to the power negative half minus root 2x times ln x, differentiation of ln x, which is 1 upon x. Now with that being said, we know that, you know, this thing can be written as half root x, and above we have root 2 ln x, negative root 2x by x, and this thing can be multiplied with 1 upon, you know, this thing is correct, so C and D is incorrect. Now the question is, which one of these are correct? As you can see, we have a ln x term, so nowhere, like in no way can you cancel that out. Ln x term must have, so B is the correct answer. We don't have to simplify it further. Okay, next question. Let hx equals x sine x. How would you write hx? So it's different, so it can be differentiated using the power rule. Alright, so power rule, how would I write? This would be the quotient rule, and obviously you can't do this, like you can't multiply with this, so this is mathematically not possible at all. But what about this? Sine has been written as sine inverse. And how does this help us using power rule? Well, none of them helps. We can use this using the quotient rule. And first of all, we're not sure that sine x can be written as sine inverse when it comes to differentiation. And the fact that even if you are able to write sine x as sine inverse x, that doesn't help you. Use the power rule. It comes as a fraction similar to a, so it's quotient rule, and this is mathematically inconsistent. So this is not possible is the logical answer. Okay, so let gx equals to sine 4x squared plus 3x. What is the differentiation of gx, which is g prime x? So sine x can be written as cos 4x squared plus 3x when we differentiate it, and we differentiate the the bracket, which is 4 to 0 8x plus 3. So 8x plus 3 and cos 4x squared plus 3x is our answer. Okay, hx is log x. Here we are referring to log base 10, h double prime x. Okay, so log basically means logarithm base 10 of x. This could be rewritten as ln x by ln 10. And we know the differentiation of ln x is 1 upon x, so h prime x is 1 upon x ln 10. What about h double prime x? Well, we can factor out ln 10 out, and we are only left with 1 upon x. So if we differentiate this thing, so it is the same as differentiating x to the power minus 1, right? So x to the power minus 1 comes here, multiplied with x to the power minus 2, because you reduce it 1, times 1. So 1 upon ln 10 times negative 1 by x squared. So ultimately this is negative 1 upon, this B is our correct answer, negative 1 upon x squared times ln 10. Okay, moving on. fx is x to the power 4 sine x times cos x. Which sequence of rules can be used in order to differentiate f in its correct form? First of all, it's the product rule. Okay, so first of all, let's say I take this thing as u and this thing as v, so u times v is product rule. Chain rule no, chain rule no. So now we use the product rule again. We have another product here, u and v. So these two terms needs the product rule again. So that's why our answer would be C. Okay, we are told to find the value of dy dx at the point 2 times 4. As you can see, we have x and y both in this equation. As a result of that, we would use implicit differentiation. So differentiation of x is 1 plus, we take 2 factored out, we use uv, let uvx and v be y. So uv means x times differentiation of y, which is dy by dx, plus y times differentiation of x, which is 1, negative 2y, and differentiation of y is dy by dx equals 0, because differentiation of 2 is 0. Now we are told to find dy by dx at the point 2, 4. So we plug 2 for x and 4 for y. And now we find the unknown here, which is dy by dx. If we can insert this into the decimals, what we would do is we would rewrite this thing as x, and we would rewrite this thing as x, just to be, a variable, unknown variable, which we will solve. So 1 plus 2 times bracket, and we have 2 into x, so 2x inside the bracket. Okay, 1 plus 2 inside the bracket, 2 into x plus 4, minus 2 into 4, which is 8, minus 8, into x, which is what we are trying to find, equals to 0. So the solution of x is what we are looking for, the differentiated value dy by dx, and they have asked for fractions, so 9 by 4 matches our working. Next question. Differentiation of cos inverse negative 2x. Well, it is, we know that differentiation of cos inverse x is 1 upon negative root 1 minus x squared. Multiplication of x, which is negative 2, differentiation of x. And we have to plug in 1 by 4 here. So negative 2 negative root 1 minus negative 2 negative 2 into x, we plug in 1 by 4, negative 2x squared. We need an exact expression, so negative 1 root negative 1 minus 1 minus, we have negative 2 into x, which is 1 by 4, and negative 2 is here. So basically this negative and negative would become positive, so there is no point in keeping this. Now, because they have asked for an exact fraction, we want this thing to be the exact. So let's calculate the thing without the root. It is 3 by 4, so it's 2 upon root 3 by 4. So this is the exact fraction, 2 divided by root 3 by 4, as you can see. So we can insert this thing to be our answer. There we go. Okay, the following table lists the values of function g and h and of their derivatives g prime and h prime for the x values 0 and 2. We are told to evaluate dy dx g of hx. So this would be g prime hx times h prime x. And because we're told to do so at 0, so we write g prime h of 0 times h prime 0. What is h prime 0? H prime is here, 0 is here. So 1, it's 1. So basically multiplying 1 is just multiplying with nothing. What about h0? h0 is 2. So we need g prime 2 because h0 is 2. So g prime 2 is 7. G prime 2 is 7, hence our answer is 7. Okay. We are given that dy by dx is this thing. Find an expression of d squared y upon dx squared in terms of x and y. So if we want to find, basically we have to do the implicit differentiation, and this thing becomes 2x negative. 2y is just 2 multiplied by differentiation of y is dy by dx. And we have to plug in 2x minus 2 into dy by dx, which is x squared negative 2y. So we're left with 2x negative 2x squared positive 2 into 4y. 2 to 2 positive 4y. So this is the answer, 2x negative 2x squared. Positive 4y. Okay, a composite function can be written as like this, where u and w are basic functions. So the question is, gx equals to log 6x squared minus 1 is a composite function? If so, what are u and w? So u is the inside thing. If we let ux to be 6x squared minus 1, the outside function could be log of x. So if the outside function is log of x and we plug in u here, this matches. So ux equals, no, this is not true. Ux could be 6x squared minus 1 because u is the inner function. Our function could be the log x. So yes, g is a composite function. So we are given ln x to the power half. This is the same as the root, and we're told to find the dy by dx. So first we use a chain rule, so half ln x to the power negative half times the differentiation of ln x, which is 1 upon x. So half ln root ln x, and we also have the x. So this is our answer. Okay. So we are told to find the limit as h tends to 0 of this function. So it's basically assuming our function is fx is 2 tan x. Okay, so 2 tan x, when you plug in, you know, and in order to find the limit, we just find f prime pi by 3. This is our answer. F prime pi by 3. If we plug in pi by 3 here, this matches exactly the formula that f h plus t negative ft upon h. So ft is this, and we also have h. So we just need to find f prime. So in order to find f prime, tan 2 into is secant square x. This is the differentiation, and secant square x can be written as 2 upon cos square x, because secant means 1 upon cos. And we just have to plug pi by 3. So 2 by, we have cos of x and square that 2 upon cos squared x, and we plug pi by 3 to get 8. So C is our answer. C is our answer. And that's it. That marks the end of this unit test.